Hello guys, I hope you're all fine. Today we are here to discuss about measurement of phase difference by using CRO. So let's get to the topic. CRO. CRO means cathode ray oscilloscope. Here it is used to display or measurement or analysis of waveforms. So now let's get to the topic. Measurement of phase difference by using CRO. Here in the CRO, two inputs will be sent. One input is vertical input and another input is horizontal input. Here vertical input is the displayed on the screen, whereas horizontal input is the ramp voltage. It is internally generated, and on CRO screen we get waveform of input signal versus time. Yeah. Here there are two input signals. If you use both the signals as sinusoidal signals, then we will get some patterns in the CRO screen. These patterns are known as Lissajous patterns. Here, these Lissajous pattern shapes are dependent on phase and frequency of those sinusoidal signals. These Lissajous patterns can be used to measure the phase difference or frequency of those signals. By using Lissajous patterns, we can calculate the phase difference and determine the ratio of frequencies. Here, let's see here. Here, if the phase difference is 0 degrees or 360 degrees, then the pattern will be straight line. If the phase difference is 30 degrees or 330 degrees, then the pattern is ellipse. Whereas, if the phase difference is 45 degrees or 315 degrees, then the pattern is ellipse. It will have some more magnitude. It is less magnitude, it will have some more magnitude. And here, if the phase difference is 6 degrees or 300 degrees, then the pattern will be in oval shape. Whereas if the phase difference is 90 degrees or 270 degrees, then the pattern will be circle. Whereas if the phase difference is 120 degrees or 240 degrees, then the pattern is oval. It will shift to second or fourth quadrant, which means it will be in second or fourth quadrant. Here, if the phase difference is 150 degrees or 210 degrees, then the pattern will be in ellipse. It will be also in second and fourth quadrant. If you look at here, if the phase difference is 180 degrees, then it will be a straight line. Then the pattern will be straight line. It will be in second or fourth quadrant. If you observe these all diagrams from here to here, then we can observe that these are changing from 1 and 3 quadrants to second and fourth quadrants. These diagrams are standard values. Now to find other than these phase difference values, there are two cases. Let's see the case 1. Here in the case 1, the phase difference will be in between 0 degrees and 90 degrees or 270 degrees and 360 degrees. Then we use the formula phi is equal to sin inverse of x1 by x2, which is equals to sin inverse of y1 by y2. If you observe here these two conditions, which means these two conditions like phase difference will be in between 0 degrees and 90 degrees, whereas the phase difference will be in between 270 degrees and 360 degrees, then we can say that the pattern will be in ellipse. Here these are x1 and x2, this is y1 and y2. These values we put in this formula, x1 and x2, y1 and y2. In this way we will find the phase difference value. Whereas there is also another possibility that the phase difference may be phi dash is equal to 360 minus phi. Now let's see the case 2. Case 2. Here the phase difference will be in between 90 degrees and 180 degrees, or the phase difference will be in between 180 degrees and 270 degrees. From 1 and 2, which means from these two conditions. From these two conditions we can say that the pattern will be in ellipse shape. But here the direction of ellipse is changed. If you look at here, the ellipse is like this, whereas here the ellipse is like this. These two directions are changed. Here the formula is Phi is equal to 180 minus sin inverse of x1 by x2, which is equals to 180 degrees minus sin inverse of y1 by y2. Here the another possibility is phi dash equal to 360 degrees minus phi. This is all about the measurement of phase difference by using CRO. Yeah, this is all about the measurement of phase difference by using CRO. I hope you understand, guys. Thank you.